Hello and welcome to Data Science in Tech, a one-hour webinar with JB Sibille. My name is Laura and I'm one of the community managers over at the Coursera community. And this is a great free resource where you can network with others, where you can deepen your learning. And the URL for the Coursera community is www.coursera.community. Our guest today is JB Sibille. JB grew up in France and went to grad school in California for systems engineering. While his background was more on the theoretical side of math and physics, he learned about the potential applications of these skills by taking Andrew Ng's machine learning course on Coursera. After diving deeper into the field during his master's, JB started working at Facebook 4.5 years ago, where he has worked on 2 different products, Facebook events and Instagram feed and stories. Welcome, JB.
Thanks. Thanks everyone for joining today. This is really exciting. It's my first time doing such a live broadcast. Yeah, I'm really excited about this, and thanks so much, Laura, for the opportunity to share a little bit more about my background and answer some questions that people may have about data science in tech. Here's I'm gonna quickly so this is today's agenda. So I'm gonna start with a quick intro. So Laura just did a little bit of an intro, but I'm gonna dive a little bit deeper into that. I think then I've received a lot of questions around the job of data scientist versus other functions. So I'm going to try to cover a little bit about this. I have gathered 3 principles that in my mind make a good data scientist that I'll try to share with you. And finally, a couple of questions that I have pre-answered, and then we can go into a more open-ended Q&A. Depending on the remaining questions. As a quick note for today, I just want to highlight that the information that we'll share today represents my own views and not the views of either my current companies or the previous companies. They're based on my current and past experiences, of course. But I wanted to highlight just this quick thing before moving forward. So let's start with intros. So as I said, my name is JB, and as Laura said, I'm French. So that means that I love cheese, hence this image. I never actually grew a mustache that big, sadly, but maybe one day. So I did my undergrad, as Laura mentioned, in math and physics in this school in France called École Polytechnique. And then I did my grad school at UC Berkeley in systems engineering. I think one thing that's interesting is when I was in Polytechnique in France, the course of studies I was taking was more on the theoretical side. Then in Berkeley, I'm more dived into the applications of this type of fields. One thing here is that there's a lot of words that I love on this slide, fromage, math, physics, and systems engineering. So I just figured that I would add a croissant because that's the last thing I really love in life. So now you know a little bit more about me. So the nice thing about this webinar today is actually Coursera is what got me into, is the website that got me into data science. So as I mentioned, my educational background was very theoretical, and I didn't really, I could solve some very complex math problems and maybe physics problems, but it was a bit hard for me to see what was the concrete applications of these problems to the industry. And so I think in these cases, the learning for me was that the best thing is usually to take a little bit of a step back. And for me, that was in the form of an internship I did in San Francisco during the summer of 2013. And there I met a couple of friends who recommended me actually this class that is now very famous. I think nearly 100,000 people have taken it to this point. And I have to say this was a little bit of a revelation to me because it really highlighted what were the potential applications of all the past knowledge I had learned and how we could apply that to real world applications and things that were really directly impacting people's lives. So as a consequence of taking this, I kind of changed the course of my master's at Berkeley. So that was right before I did my master's. And I really switched my focus to be more on data science and programming, where I worked on a couple of projects, such as this little course project around like trying to infer next destination of drivers using some historical data that a startup had kindly agreed to share with me. After my master, I joined Facebook, where I've worked on mainly two products. First, Facebook Events, which is the product that helps you, either organize your birthday party with your friends, or that helps your local bar organize its weekly trivia night or something like that. And then I joined Instagram Home, which is basically Instagram feed and stories. So if you use Instagram, this is everything that is happening in the first tab of the app. I worked on a lot of aspects of Instagram Home and feed and stories. And then I became a manager about a year and a half ago. That helped me also gain a little bit more perspective on the role of data science. So I think one thing that was like interesting is that this sounds a little bit maybe as a very linear course, but actually before joining Facebook, it was a little bit tricky because data science is really an overloaded term these days. I think like what people mean by data science ranges from everything from like artificial intelligence, like some SQL, some business intelligence, some machine learning, growth marketing, data engineering, product analytics, anything like that. So I figured that maybe as a first step for this webinar, it could be helpful if I start by giving maybe a little bit of my take on the difference between all these functions. Hopefully that also can help some of you determine better like where they want to head. So we go into the second section, which is about like how to think about the job of a data scientist. So in my mind, there are really two main dimensions to consider. As a big disclaimer here, this is like really my view based on my experience here, and I think it may really vary by organization, especially for smaller companies where lines are very blurred. But I think that these two dimensions can still be very helpful for you if you're, for instance, applying for a data science job to understand what type of job you're actually going to be doing. So this could be helpful questions to ask to recruiters and interviewers, for instance. I think the first dimension is very important. It's like, is my core responsibility going to push production code? So are you going to be someone who is going to write code that is going to be frontline and what is going to actually be used in production for the application that the company is developing? Or actually, are you more trying to influence on the strategic side? Of course, a lot of roles have like both responsibilities, but I think here the idea is like, what is really the core of the job that you're applying for and what are the core expectations? The second question that I recommend asking is like, will you be embedded within a product team or actually part of a centralized data science organization within the company? Again, there are various mixed models here as well, but I think that it actually makes quite a big difference in your day-to-day operation. So I think these two dimensions are important because the first one is really like kind of, if you think about the longer term arc of what you're doing, it's like kind of over time what you will tend to be doing more. The second question is more related to your day-to-day and like how you really like, what are your core responsibilities on the day-to-day? So with this in mind, like there are, kind of like this 2x2 matrix that you can drive. Either you're in a centralized organization where you are in an organization where data science is centralized or it's embedded within product teams. And either you are more pushing code to production or have more strategic influence. So some examples of like potential teams that are like more centralized and push code to productions are going to be like AI research team, for instance. Again, like this is just an example. But that's because, like, generally speaking, these teams are relatively small and there's a lot of advantage having them all together. And that creates a lot of like cross-pollination. An example where like you would push some production code, but you're actually embedded within a product team, so responsible for a product such as like, let's say Instagram stories, is ML engineering. So in this case, you're a machine learning engineer that has a very specific mission related to the product of the company. I think like in terms of like centralized organization with strategic influence, like one thing that I'm thinking about here is like more on the business intelligence side, like what is generally called business intelligence. One last thing is something that's a little bit in between production code and strategic, but is an embedded model, is data engineering, where sometimes you will touch on production code. You like try to build all the data, the data pipelines to make them available to everyone. But sometimes you also work a lot with like offline data sets and things like that. And in my mind, where data science and analytics sits is really at this intersection of like, your core responsibility is to have strategic impact on the direction of the company. And at the same time, you're really embedded in a product team, so you have maximum context on the direction that the team is having. So for instance, you work on Instagram stories and you really try to like influence the direction of the team based on data. So today I'm mostly going to focus on data science and analytics because this is what I know the most about. But of course, like, you know, maybe I'm not an expert in any of the other fields. So I'm not going to take too much of a take on these domains, but I'm sure there will be other webinars on the community that may cover some of these functions. So I think, like, in a nutshell, the way I would describe a data scientist is that our core responsibility is to understand product trends and identify new opportunities. One way that a former leader of mine used to frame this in 2 questions was pretty interesting, I think, is like, first, there are 2 questions you should always be asking yourselves. The first one is, what is the most important question for the company or for your product team right now? And the second one is, how can data help answer this question? So for the first question, I really highlighting the most important here, because I think that it's very easy to like fall into the trap of like starting to work on questions that are like very interesting, but not very important for the company. You can figure out what's important, for instance, by talking to the leaders of your organization, talking to your cross-functional partners, or anything like that. And the type of questions that will come to your way are really more high-level questions that are not data questions, but that are like strategic questions. Should the team start working on product X? Should we continue working on Y, or should we stop working on that? We're launching a certain product. How can we measure if it's going to be successful? So these are the type of questions that you're going to be asking yourself. And then the next one is like, how can data help answer this question? I'm going to dive a little bit more into that second question now. But one thing that I want to highlight now is really the fact that there's this word help in here. And I'll dive in a very short time why I think this is so important. So in the next section, I'm going to cover like 3 principles that in my mind really make for a good data scientist. So the first one is that I think we should really try to strike for companies to be data informed and not necessarily data driven. I think that like it's a common pitfall to really try to over optimize for either a certain metric or over optimize for certain things. But the reality is that when you work in data science in tech, especially on a consumer product, in the end, the people you're trying to like optimize for, like the thing you're trying to optimize for are people's experiences. And the reality is that it's very hard to put like hard numbers that perfectly represent these experiences. Of course, you're going to have approximation of these, but you can always, but you're going to have approximation of these. But in the end, like you always need to take a step back around the numbers that you report on in order to keep in mind this user experience all the time. The way I illustrate this as well is like, let's say that you're in a product team, and this dot at the middle of the screen right now represents like what your team currently knows. Your team is trying to work on a new product or something like that, and it's trying to understand the direction it should take. So basically, if you think about it, it's like kind of like you have this circle that's like around the team, it's like around where the team currently knows, where the team needs to take a decision at a certain point in that circle. What data can really help you do is identify like maybe an arc within that circle that narrows the possibilities where the team should really orient itself. But it's important to keep in mind that there's always a knowledge gap, and you're never going to get like a perfect sense of what the team should do. And this is why I think that successful data science really requires working very closely with other functions. These other functions tend to be, generally speaking, product management, user research, that give you a bit more of a granular view on the actual like experience that people have. Data engineering, which I covered a little bit earlier, which really helps like sometimes automate some of these analyses that you do a lot. Product design that help like identify problems and solutions to certain problems as well, so to the user experiences. And engineering, of course, which helps build the solutions that we're coming up with. So this is really this like really important concept that I want to highlight, is that data science in it by itself is not like is amazing, but it's really about this collaboration with other functions that will help you build like amazing product experiences especially over the a long period of time. I really like this quote from this French philosopher from the Enlightenment that says that science without conscience is nothing but the ruin of the soul. I think that it also applies a little bit here, where like if you try to over-optimize for certain numbers that always are going to be imperfect, you're never going to lead to good outcomes over the long term. The second principle I want to talk about is being hypothesis-driven. I think the way to summarize this is that it is your job as a data scientist to really help prioritize work that leads the team, sorry, I forgot the word in my presentation here, that leads the team to answer the questions it has faster. So one way we work is really we try to understand how people use the product and how it may improve and how we may improve the user experience. I think like one thing that's important here is to get to the answers that are the most important to the most important questions first, and as fast as possible, and to do the simple things first. So for instance, let's say that you work on an events product and you want to know, you have the suspicion that people use your product a lot to organize birthday parties. Well, you could approach this question in a very complex way by thinking like, oh, okay, birthday parties, you don't have structured data around that because like, let's say it's a very open-ended product where you don't necessarily select the category for your event or something like that. So you could approach the question in a complex way. You're like, I'm going to build an NLP classifier that's going to like, an NLP model that was going to identify what strings people are inputting in the event description and things like that. But the reality is that you can also just have a very simple approach, which is you can just look for like occurrences of the word birthday into the title and the description of events. And that already will give you like almost 80%, 90% of the answer that you need. And it's like something you can do within an hour. And that can really help push this hypothesis further and the product team further. So it's a little bit of this difference between like building a very complex thing and building something quite simple that leads you to like a lot of the outcome that you're looking to get to. The third principle that I want to highlight is that as data scientists, we really are supposed to embody prioritization. To the point, to go back to the second principle, there are many hypotheses that we could test as data scientists. And we have also many tools to do that. You know, we can do a random A/B test, we can do offline analysis, we can do a lot of things. But really what's important is to identify what are the most important hypotheses and the most important things that you need to like to get to an answer first in order to answer the questions you need. So I think one way to frame this as well is that to some extent you're accountable for the team's priority. And to retake the example that we had earlier around like data helping identify like an arc of possibilities, if data identifies this arc that I highlighted here and the team actually decides to go in another direction, it is your job to really hold the team accountable to influence the team's direction and eventually land on what makes the most sense. And I think that actually hints to like one of the most important parts of what we do, which is that we have to keep people honest in teams and like to make sure that like your company or the team you're working with is prioritizing the most important things first in order to and to keep people like really this aspect of like intellectual honesty to influence where the product is going and to avoid making mistakes. Over time, of course, like maybe you can have, if you don't follow these principles, you can have a couple of like lucky strikes and build great products that are not data informed. But over time, like it's likely that you're going to start making bad decisions and the product is going to die. So these were like the three principles I wanted to cover. The next point I want to make, I have a couple of like quick hits about questions that I've gotten either in the offline in the forum earlier, or just questions that I usually get from people when I describe my job. So I wanted to take a chance to quickly answer them. So the first one is really, I think, very common is like, how do I get into data science? Um, I think there's no currently, I mean, there are a couple of like data science masters and data science programs that start coming up around the world. And I think these are great. I think one thing that I want to highlight is that there's also a bunch of different backgrounds that can lead you to data science, whether your background is in statistics, in mathematics, in physics, in operational research, anything like this can really be relevant. I think what matters most is that you have some baseline background of statistics and probabilities. And also that I think a nice thing about these fields that I mentioned above is that they really help you develop critical judgment and intellectual honesty, which is a critical part of the job. That being said, you may do all the classes you want, and you may do all the online classes, or like go to a master's, or you do a PhD in these fields. There's nothing that trumps practice. And there's really no data science without data. Otherwise, it's only science, and then we go back to the point above. And so I think one thing that's really interesting is like to try to get exposure to like actual concrete problems as soon as possible to start understanding a bit better like what the industry actually looks like. So for this, if you're not currently working in a company that has data accessible, there are more and more open data sources. For instance, I know that like New York City has like a whole push to publish a lot of data. I live in New York City, so that's why I'm talking about this. So there's a lot of like more and more open data sources, but most of the data in the world sadly is not public. So I think what's really interesting is also if you're a student to try to partner with a company on a school project. So that's one thing that I did. Companies are usually pretty happy, especially startups, because that gives them some free work. And you also get you also get exposure to some actual data from real world products. So that's like something that's quite interesting. I think one general thing as well is like try to think about like different real world applications, and even if you don't have like data available, try to think about how you would solve problems. So for instance, one thing that I like to think about is like if I was the head of the MTA or the head of the data department of the MTA, which is like the transport administration of New York City, like what data would I collect and what would I do with this data? I think in general also like it's a good thing to self-reflect and to be asking yourself whether when you're faced with a problem, whether you try to think analytically about that problem and to answer these questions using data, and that can be a pretty strong signal of whether this is something that data science is something that would be for you. Someone was asking me about bootcamps in the Q&A, in the offline Q&A. I'm not super familiar with the various data science bootcamp that exist out there. I think that like they might be great, especially if you already have like some previous like understanding of statistics and probabilities and math, for instance. But I do think that it's important to get the deep technical knowledge to interpret results and things and talk confidently about your work. So some people can learn on the go, but I think that like for this, there's like little things that like school is probably still like one of the best ways to get exposure to this. Another question that I get asked often is like, what are some of the key skill sets to have as a data scientist? I think like when I was trying to think about this question, there's like 4 main things that came to my mind. First is like being analytical. So that's like kind of what I covered also in the previous slide. Is like, do you try to approach problem from an analytical perspective? Do you try to decompose problems into like sub problems and understanding how you can do the simple things first and everything like that? And that's like a little bit of a very key things that that I think is important as a data scientist to have. Also, are you like product and people focused? So again, to the point I was making about data driven versus data informed, in the end, when you work for a company, you're building a product that people will use. And it's really important to keep that in mind all the time and to not get drowned into the metrics and the numbers that you can be exposed to as a data scientist. In some cases, you'll have like infinite amounts of data and you have infinite amount of work you could do with this data. But if you really have this hypothesis first approach and try to think about people's experiences first, it really helps you narrow down the realm of things that you do. The third point is communication. As I mentioned above, data scientists embody prioritization, and a key way to influencing a company in prioritization is to be able to communicate clearly around your results and your insights. So if you have the best analysis in the world, but you keep it for yourself and nobody else sees it, then you're not going to influence anything. And the impact you have is actually zero. So it's quite important to keep that in mind always, is like, what is the right like balance between like doing additional work and doing and communicating around that work. To the point that was the example I was giving around like understanding whether like events or birthday parties or not. It's probably better to spend like 1 hour doing this analysis and then 1 week communicating than the opposite if you are going to build an NLP model first and everything. That also helps you gather more momentum and then like helps you gain more clarity, gain more momentum and like buy-in from like various stakeholders to help you actually then focus more and go deeper. Because of course that analysis that I just suggested was like has tons of like problems and biases and things like that. And you would want to like go deeper in order to like make a really informed decision. Finally, I think it's important to have a good sense of like data structures. So this is something that's like a good representation. Like for instance, I highly recommend taking a SQL class at some point, even though SQL might not be your favorite language. It has, the way it structures information is really how I think it's helpful to think as data scientists. So I highly recommend doing this at some point. Understanding statistics, at least basic statistics and probabilities, is also quite important to the point I was making earlier, to be able to express your results cleanly and clearly and confidently. So the next question that I often get is, what does a typical day look like? As you can imagine, the answer to always this question is it depends. But I think that over my time as a data scientist, I have identified four main types of work that I've been usually doing. And they'll depend on like the product and the company that you're working in. So I'm going to start from the top here to describe a little bit more what I mean here. But for instance, I think at the top level, if you work on a 0 to 1 product, something that doesn't exist yet or something like that, it's really important to be able to build a vision for that product and to translate that vision into data in some form. So for instance, that can mean like defining the success metric for that product or that company. And maybe it's something like a 3-year horizon plan. So let's say that you're building an e-commerce company. Like a success metric is probably around like a growth amount of goods sold. And like your 3-year plans could be like, I want to be like 1% of Amazon or something like that. That's of course maybe a little bit ridiculous for something that's starting, but like that just to be something that has to be inspiring, but at the same time achievable in order to really like gather momentum and also anchor it into like an actual data point so that you can hold people accountable over time for for how the company or the team is actually performing against that goal and whether you should revisit some of the assumptions. So the second set of work, once you've set that 3-year vision, is to actually maybe break that down a little bit more into like 3-month increment or things like that. And for this is going back to the being hypothesis-driven principle. It's really about like, what are the things that if you need to get to that point in 3 years, you want to prove first? Like, what are the things that you want to prove in the next 3 months? And that if you don't manage to prove this within 3 months, then that means that that means that some of your key assumptions are probably wrong, and you need to revisit either your vision or your direction, or to pivot the team, or to pivot the company, or something like that. So on this front, you will develop, when you work on strategic questions, maybe a bit more like granular metrics. So for instance, if you're building an e-commerce company, maybe you want to have a checkout flow with a certain like a certain checkout rate. Because if you don't have that, then you're not going to be able to achieve your long-term vision. And so in this case, you'll try for like a couple of months to like improve that experience for the users. And you set a goal around it. And if you don't manage to get there, then of course you can like that leads to revisiting maybe some of your core assumptions and maybe the direction of the company. This is also like quite high level. Because it's like 3 months or maybe like a year plan, but of like what the company or like what your team should focus on. But it's also quite important because if your strategic plan doesn't build up to your vision, then that also means that you're probably not working on the right things at this time, and that it's better to realize this early rather than later, right? So once you've set your strategy, let's say for the next 3 months, it's a lot about like doing more tactical work. So let's say you want to achieve a certain goal for your checkout flow and have a certain checkout rate. What are the tactical things that you can do to get to that point? And so here you're going to do some specific analysis related to that checkout flow. Where do people drop off? Like how much time do they spend on it? Like all this type of things, like the classic like analysis that you can do on this type of things, and make recommendations based on this, like very tactical recommendations of like, hey, we should probably focus on this part of the flow because like people are inputting their credit card number, but they're not putting their expiration date or something like that. Like maybe there's something that's broken here. And here you can have a lot of wins that way. Finally, the last piece that is quite important is the operational work. And this is like among the 3 types of work that I mentioned above, vision, strategic, and tactical, you have to set certain metrics and certain goals that will represent the success for the team and for the company. And I think that like with this operational work, this is about like really tracking how you're doing along the way with these things. So whether it is like some engineers that have like started experiments or A/B testing, for instance, like being able to help them interpret the results of this test, understand whether this is something we should move forward with or not. So this is something that's like actually quite important to keep in mind as well. And reporting on metrics on a regular basis. It's a core responsibility of data science as well, in my mind, to be able to hold the teams accountable to like the actual success in practice against these like tactical, strategic, and vision goals. Cool. So another question that I often get, and that is related to an area I covered earlier, is should I join a big company or a startup? Again, there's no right answer here. It will really depend on you, on the company, on like your motivation for the specific team or some things like that. I just have like maybe 2 quick high-level thoughts on this, which is that the type of work you will do in each is probably quite different. Startups, generally speaking, need to spin up a lot of their data engineering effort, and like because they don't have any data structure in place and things like that. And so that's probably a bit more of the type of work you tend to do in a startup, like setting up end-to-end like pipelines and things like that, or dashboard, like very early dashboards. The good thing about startups as well is that like because usually nobody has ever looked into this data before, you have a lot of like low-hanging fruits, and this insight can have pretty dramatic impact on the direction of the company, which is like pretty fulfilling. In big companies, it's quite different. You usually have a lot of data available to you, and it's a lot about you have to do a lot of prioritization because this data, like you could really spend month and month and month digging into the data. But it's quite important to like focus and find again what are the most important questions to answer first. I think also in big companies you tend to have a bit more role clarity. Like big companies can afford to have like a dedicated data engineer, a dedicated data scientist, a dedicated AI person, a dedicated ML engineer, and so your role will probably be a bit more specific than if it is in a startup where you might have to like do production code one day and then like do some strategic analysis the other day and things like that. I think also that, so that can, for some people that works better. I think the key thing about this is that it usually enables you to go deeper on some specific, questions. Especially because like when it's a mature product, small optimizations can lead to a lot of consequences. If you improve like a number of users on a platform that already has 1 billion users by like 1%, that is like literally 10 million people that are on the platform, and you can imagine that's like a pretty big impact. The other question that I often get is like, what are the tools that I should learn to be a good data scientist? I think here again, there's no right answer. Sorry, it's like I know that the last 3 slides were like there's no right answer, but it really depends on what flow works best for you. I think like, as I mentioned earlier, understanding SQL, at least maybe not being an expert in SQL, but understanding SQL is pretty helpful because this is really how data is stored. And if you want to be able to work independently, you will have at some point to query some SQL database. And so that's pretty helpful to know, at least the basics. But then once you've extracted the data, you can use really whatever tool you want. You can use Python, you can use R, You can use MATLAB or anything like that that supports the applications that you're trying to do. Python and R tend to have like pretty extensive libraries that are open source, so that's pretty convenient. And they also have developed like really good notebook systems in the past couple of years that enable data scientists to create good workflows that are that can be automated. There's also a lot of like open source like dashboarding tools now and like pipelining tools and everything. So this can also really be helpful in order to like get started, especially if you're in a company that doesn't have a pre-existing set of tools that they're using. The last point I want to make is about metrics. So I talked a lot about this in the past, but I think one thing that sometimes gets overlooked with metrics is, again, to this point of being data-driven versus data-informed, is that it's important to keep in mind that metrics are representations of objectives for the company, and there never are perfect representations of objectives. Objectives are actually like around solving user problems, solving people problems, solving like real world problems. And we try to really build better metrics or KPI around these things, but you never really get like a perfect representation of it. So I think that's just something that's important to keep in mind, always to like take a step back on your metrics and to really consider every time you make changes to whether that's something good for actually good for people or not. And it's also important to never like hyper optimize for metrics, and to first build the right products and to try to reach the objectives that the more like verbal form of your objectives, and usually that will translate into like metric wins and everything like that. One last thing on setting goals. I think that it's pretty important to set goals on like key metrics. So in the case of like, in the case of an e-commerce platform, maybe like setting a goal around sales and things like that can be pretty important. And I think one thing that I see sometimes happen with goals is like either is setting goals that are like for sure achievable. Well, I think this sometimes can feel good. I think over the long run, what's really important is actually to set goals that will challenge your assumptions, and to set goals in a way that like you have a goal on a certain metric that represents a user experience, and if you miss that goal, that will make you question some of the core assumptions about your product, and that can change actually the direction of your company or your product. That's all I have prepared for today. So thank you everyone for coming. And I guess now we can take a couple of questions.
Yes, thank you, JB. There are a lot of questions in the Q&A feature. If you want to take a look in there and to read through.
All right. So what are the approaches to get into a data science career? I think I'm reading them in chronological order right now. To get into a data science career, in particular, how to get a first job / contract, and what are the education background that are in demand in the industry. I think I answered most of this question during some of the slides, but I'm happy to get back to it if there's any follow-up. What are the hot topics and unresolved problems in data science? I think it really depends on the company you're in and the product you're working on. Different companies will have different problems. I think, yeah, I don't think there's any, I mean, in my mind, there are like, maybe there are some like key societal questions that can be answered with a bit more data science in them. I think, yeah, like the example I was talking about being the head of the subway system, or like the data subway system, that I think could be very interesting, for instance. But no, I don't have any specifics in mind here. It really depends on the company you're working for. Moving on. So there's a question, I should have maybe preface with this, but I can't really talk about any specifics of my day-to-day work. So this is the question around like specific tasks that I'm solving at Instagram. So I'm probably gonna skip this one. Difference in roles and responsibilities, data engineering versus data scientist versus data analyst. So I touched a little bit on this. I think there's a couple of differences. I think like on data engineer versus data scientist. I mean, first of all, I think there's like a little bit of a spectrum here because again, it will really vary based on the company, and like smaller structures tend to have less structure, smaller companies tend to have less structure around these roles. But I think data engineering, the way I like to think about it is like really tries to automate a lot of the work that data science does. So if you think of a dashboard, for instance, a dashboard that updates every day is an automation of something that a data scientist could do on a daily basis as well with a manual query. So that's a little bit of like something that I think about. I'm not a data engineer either, so it's like I don't have the full spectrum of like what are all the differences. I think also like setting up like core infrastructure for data science to be able to do work more efficiently is like a pretty core part of data engineering. Data scientist versus data analyst, like I'm not really sure. I think this one is very clearly a spectrum. I think what sometimes I hear is that data analysts tend to focus more on like the operational part of the role, like what I was talking about in like what I do in my day-to-day. I think data analysts tend to focus more on the operational part, and data scientists a bit more on the like strategic part. But I don't know if that's like a systematic thing. And I think like this tends to be maybe just more of a linguistic thing, and like I wouldn't necessarily over pivot on this, but I think it is important to understand what the core expectations are in a role that you're joining. And a data scientist role, in my mind, is really one of the key responsibilities is to have strategic influence on the company's direction. Which language is good to learn / focus between R versus Python? How much statistical knowledge is enough? What types of statistics is descriptive? So R versus Python, honestly, this is like a question of preference. I prefer Python personally, but that's just because that's what I learned first. But some people prefer R, so I really don't have a good sense of this. From what I've seen, like there's not much that you can do in Python that you cannot do in R and vice versa. So I wouldn't necessarily optimize on this. I think one advantage of Python is that it tends to be a bit easier to put in production. But even then, like I'm not entirely sure that's like that's a systematic thing. How much statistical knowledge is enough? I mean, it's quite interesting. I think like you need, as a data scientist, like you're going to be probably interpreting results from A/B tests, for instance. So understanding key concepts such as like confidence intervals and things like that, and like hypothesis testing is really, really important. And by saying this, there's like a lot of underlying theory behind it. And so having a good grasp of this underlying theory is actually, in my mind, quite important. Again, to be able to really speak confidently about your work. My experience for applying for my first data science job. Yeah, sure. I think actually I covered a little bit of this as well. So when I was in school, I contacted a company that was created by some alumni that kindly shared a little bit of data with me, on which, based on which I did a school project that I also showed a screenshot of at the very beginning. And because we had a pretty good working relationship, I did an internship in that company right after, and that really helped me learn more about actual industry practices and things like that. What advice? So that I think is a good way, generally speaking, to get into a data science job if you're in school right now. Otherwise, I think doing side projects can be pretty helpful. Like to the point I was making, there is some open source data, so showing that you actually can have that analytical mind can be pretty helpful. What would be your advice? What would you advise be to prepare for an interview when you have no relevant work experience? Yeah, I think it's usually recruiters try to help you understand a little bit better the expectations for the specific jobs that you're applying for. So I think it depends a little bit on the company you're applying for and things like that. but you can definitely try to learn more about like I think learning more about the product and being very familiar with it is kind of a need because like you will probably have like, I mean, in the end, data science is applied to a product, and so I think that like that is something that makes that can be pretty helpful. Other than that, yeah, like being up to speed on like SQL data structures, generally speaking, like your stats and your probabilities can be pretty helpful. In the embedded data scientist role, you describe how much of your day-to-day revolves around linear regression and other models, and how much revolves around simpler metrics about data such as counts, averages, etc. To the point I was making as well, like it really depends. It depends on the project that I'm working on. It depends on the question I'm trying to answer. One thing for sure is that I always try to do the simple thing first. I really believe in like the 20/80 rule, and it doesn't always work though. And so I usually try to like answer the questions that I have like with very simple methods. And then you know, if I need to go a little bit deeper, I think also it's important to not conflate like simple with inaccurate. There are some things that, you know, like for instance, like you pull a simple regression and you're like, oh, well, that looks to, you know, that points in a direction, but then you overlook like potential Simpson's paradox or things like that. So I think there's like it's quite nuanced, and usually like you probably want to have your basis covered and to do like a bit more than what is actually required to have more confidence in your results. But yeah, it will depend. Like in my career, I've had to build some like more complex models, and sometimes I've had to sometimes just a count can be very impactful. You know, like people don't know how many people are using your product, then just doing a count on a database can answer this question, and that can be a pretty big deal. So yeah. I think it's really about like thinking about the impact of your work rather than like the type of work sometimes that matters. Yeah. I'm a data science student and want to find a job as a junior. I am a data science student and I want to find a job as a junior during my studying that helps me gain useful experience and prepares me to become a data scientist. What is your recommendation? From where should I just start? I think I answered a little bit of that question earlier in during your presentation, so maybe I'm going to skip it for the purpose of time to get to other questions. Is it possible to sell data science as a service? What would be the role of a sales engineer pre-sales be? Or do you only see data science as a role for 100% technical role? That's I mean, I think data science can be a service. I think there are a couple of like consulting firms actually out there that are starting to spin up some data science departments. So so it definitely can be a service. I think the trick here is that as I mentioned, like in my mind, a very successful model is when you're really embedded within the product and understand the product. So regardless, you will need to understand that and spend some time understanding these things. So there's a ramp up phase. Also, one thing about data science is that like you need to ensure that there's data to work on. So sometimes you'll work with a company and like they, you know, maybe they don't have the right data structures in place and things like that. So that's something to account for. I don't think it's a 100% technical role. As I said earlier, like I think a key part of the role is around communication actually. So there's definitely room here for like different skill sets, but I think the core of the role is technical, which is something that cannot be overlooked. Can physics be replaced by data science if we have enough data? How confident we can be with the results? That is a very broad question. I don't think we can replace an entire field of science with data, but if the person who posted that question has more specific question, I'm happy to try to answer it, although my physics knowledge is like a bit like old at this point. Do you know sites which can give us free data on stock prices for data analysis? I'm not super familiar with like the stock market data. So actually, I actually don't know any sites like this, but I'm sure there are some things that exist. One thing that I recommend as well is like you can start simple also depending on what you're trying to do. You know, if you're just trying to maybe you can just pull like the historical data for a single stock using like Google Stocks or Yahoo, like Yahoo Stocks, and then like from there see if like your model works or something. Anyways, yeah, I'm not super familiar with this area of data science. Is a particular programming language preferred regarding data science at workplaces? I'm familiar with R programming language, and I have used it for data analysis and machine learning during my academic work. Is knowledge of big data tools essential for data scientists? What tools do you use at work, at your work? So R is great. Again, R, Python, I think all these things are great. I'm not sure what big data tool, what is meant by big data tools here. I definitely think that it depends on the type of data you're working with. Like if you have large volumes of data, you know, being familiar with things such as Hive and maybe even Presto can be helpful. Some of the tools, I mean, what tools do I use at work? You know, some tools are like internal, some tools are external, and I can't really like give too much details about this. Some tools were released by Facebook as open source projects, such as like actually Hive. Yeah, that's an interesting thing to think about. How would you approach an unbalanced data set problem? For example, predicting fraudulent transactions in a bank. I've been using Smoot and Edison. I'm not exactly familiar with this. Like, so if the person wants to like give a bit more details, I think like maybe that's something that would be more relevant offline. Can you explain in more details how to be data informed versus data driven? Thank you. I think it goes back to what I was saying here around the metrics at the end, is like the fact that data is always an imperfect representation of reality. And reality is actually like people having experiences with your products. So you can try to improve what that representation is, and you should always strive for like better representation. But I think in the end, what I mean by being data informed is that you can really help an organization by showing relevant data that will help avoid making big mistakes. But I think also that what I mean by that is it's important to consider data is only part of the answer, and it's important to collaborate with other functions such as like user research and in-person interviews, or like, you know, product design, for instance, to really build a full opinion and make before you make a decision. Is there a lack of understanding on the part of companies about data scientists? Task assignments are very different comparing companies. I don't know if like companies don't understand data scientists. I think like each company has its own needs. In my 2x2 chart, I try to like summarize a little bit how I think about the different functions. But I think that it's really important to have, I think that data science really suffers from its own success of like having a title that is like overused for different things. And so I really think it's important to gain clarity before you accept a job on what exactly are your core responsibilities and what you'll be doing on a day-to-day basis. I have a PhD in mathematics, and recently I turned my interest to data science after completing the machine learning and NG's course. Someone with math background would be interesting to the industries. I don't think that's a question, so I'll just go to the next one. Do you think, is it possible to work as a data scientist freelancer? I mean, I think it's definitely possible. I think, again, like there's some consulting possibilities in general, and like some companies don't necessarily have like the resources to like build a full data science team from within. So that might be an opportunity. And again, I know that some consulting firms are starting to do this as well. So yes, but I think that there is definitely like some ramp up on every project that you need to do, and potentially you'll spend a lot of time actually like building the data structures rather than doing analysis. But that is just something to be conscious of, and it's not necessarily a bad thing if that's what you enjoy doing. Is Facebook hiring now? How to get into Facebook? What are interviews like? You can look into our career sites for more details on this. And then the last question is, what is the most fun data science thing you have done or are doing at Facebook? So again, I can't really talk about my projects, my actual work at Facebook, so I'm not going to dive into details here. But before Facebook, there were a lot of like interesting projects that I worked on at school around like I think that project that I highlighted at the beginning around like trying to predict like people's next destination in their cars using like their historical data. Was pretty interesting. Especially like trying different models and understanding what was more fit for this type of prediction. But yeah, that's basically it. And I think that was the last question. So Laura, and then we're about time. So I don't know, Laura, if you want to jump in or. Yeah.
Yes, I'm here. Yeah, thank you all for the many, many questions. And thank you, JB, for fielding the questions and for taking the time to talk with us today.
Thank you so much, Laura, for the opportunity. And thanks everyone for coming and asking really good questions. It was really fun to do this exercise.